Okay, welcome. This is a Math 124 review. I'm going to be going through some problems that were on the 124 practice final review sheet. So I'll dive into it. Here we go. I'll start with number one. It's graph a line. So I'll pick, let's say B, and it says y equals -3/2 x plus 1. And so I've got this in slope-intercept form. You might recognize y equals mx plus b. So m is my slope, and b is the y-intercept. So graphing this just requires those two things. I have a intercept at +1. That means my y-axis at 1. I cross over there, so I have a dot there. And then I have a slope of -3/2, which means as I go to the right 2 spaces, I'm going to go down 3. So 1, 2, 3 down, and 2 over lands me here. And then I just need to connect them with a straight line. And there we go. Right? And then this is, of course, a line that goes forever. So we throw arrows on it. Goes on that way forever, goes on that way forever. So if I have an equation in this form, y equals mx plus b, it's that easy. Find the y-intercept, find the slope, and find the second point using that slope, and you've got your line. Looking at number, let's say 2. Here is the points 7, 2, and -3, 13 are endpoints of the diameter of a circle. And the question is, determine the center of the circle, right? So really, if I have this circle, right, the picture, whatever's happening here is I've got an endpoint here, an endpoint there. It's a diameter of the circle, so it goes through the middle of the circle, and the middle of that circle is the midpoint of these two values, those 2 points. And so you'll need the midpoint formula for this. But that midpoint formula is just the average of your x values. So x1 plus x2 divided by 2, and then comma, the y value is the same thing, y1 plus y2, all divided by 2. And that's your midpoint, right? Just averaging those together. So call one of these points x1 and and y1. And the other point, call it x2 and y2. And we just add those together. x1 plus x2 is 7. Plus x2 is -3, so I'll write it plus -3 all over 2. And then I'll do the same thing with my y values. y1 is 2, plus y2 is 13, and I divide that by 2. And I just simplify each of these. 7 plus -3 is 4, and 2 plus 13 is 15. And again, I can simplify a little bit more because 4 over 2, that's just 2. So I have the points 2 and 15 over 2, and that's my midpoint, and therefore the center of the circle. Let's look at problem 3. Could the following points be vertices of a right triangle? And we're given the points -4, 5, 6, 1, and 8, -8, and -5. Right? So in order for these to be the vertices of a right triangle, what we would have to do, and it says here in the problem, hint, find the distance between each of the points and then test the Pythagorean theorem. Well, if I have a right triangle, then I have a squared. If I have side A, side B, and side C, if it's a right triangle, then a squared plus b squared equals c squared. So I want to find the distance between each of these because each of these points is the vertice of some triangle. It's those 3 points. And so if I find the distance between any two of them, that would be the sides of these triangles. And so I'm going to find the distance between A and B. So we'll call this point A. We'll call this point A, we'll call this point B, and we'll call this point C. And so I want to find, to start, the distance between point A and B. And that is, of course, x squared, x1 minus x2 all squared, plus y1 minus y2 squared. So we'll just call one of these x1 and y1, and the other one x2 and y2. And so it's just the difference between the x values. So it's -4 minus 6. And then the y values, the difference between those is 5 minus 1. And then I do the subtraction or the addition inside the parentheses first. So -4 minus 6 gives me -10, and that's still squared, plus, and then 5 minus 1 is 4, and that's still squared. So this is 100 plus 16, or the square root of 116. And I'm not going to simplify that any further, because when I plug this back in, I'm going to plug it into a squared plus b squared. And so I really only care about, when I square it, I'm going to get 116. But I want to do this for each of the 2 points. So that was A and B. I want to find the distance between A and C, and then also the distance between B and C. So let's find here the distance between A and C. And that's taking the difference of the x values. So the x value of point A is -4 minus the x value of C. So that's minus -8. And that all gets squared. Plus the difference in their y values. So 5 minus -5. And that gets squared. So if I simplify inside, -4 minus -8, that's like +8. And so I get -4 plus 8, which is still -4. Or sorry, is not minus, is 4. And that's still squared. Plus 5 minus -5 is the same as 5 plus 5, so that is 10 squared. And this guy actually turns out to be 16 plus 100. It's the same value. All right. Now the last thing that I want to do is find the distance between point B and point C. So I will try to find a place to do that here. The distance between B and C is, and I'm going to scroll up here and find those values, the square root of the x value of B is 6 minus the x value of C is -8. So minus -8, I'm just going to write that as a +8 because that'll simplify that way, squared. And then plus the difference between the y values, well, the y value of B is 1 minus -5. So that again becomes the same as +5. So here I've in the left parentheses, 6 plus 8 is 14 squared. This is 1 plus 5, so that's 6 squared. And then 14 squared, I lost my marker, is 196, and then plus 36. And that ends up being the square root of 232, right? So obviously in the Pythagorean theorem, I get a squared plus b squared equals c squared. C squared obviously has to be the bigger of the three. And so this guy down here is my potential c. And so this thing is true. It is a right triangle if in a squared plus b squared equals c squared, I let a squared equal the square root of 116 squared. And then plus b squared is also going to be the square root of 116, and that gets squared. And if that's all equal to the square root of 232, that gets squared. Then this is true. So the squares will kill the square roots. That leaves me with 116 plus 116 equals 232. And in fact, this is true because 116 plus 116 is indeed 232. So the Pythagorean theorem is satisfied, and therefore this is indeed a right triangle. Okay. Let's look at problem 4. So problem 4 says, is the point the square root of 3 over 2, comma, negative 1 over 2 on the unit circle? And it tells us that the unit circle is the circle centered at 0, 0, 0, with a radius of 1. So that is to say mathematically that it would satisfy the equation of that unit circle, which is x squared plus y squared equals the radius squared, which is 1 squared. So that's just 1. So if I plug in my x value into that equation, and then I plug the y value into y of that equation, and it is true, then yes, it is indeed on the unit circle. So I'll replace that. Instead of x, I have the square root of 3 over 2, and that whole thing is squared, plus y, which is negative 1/2, but that whole thing gets squared, should be equal to 1. Now if I square, I'm squaring both the numerator and the denominator, so the square of the square root of 3 is just 3, but then the square of 2 is 4. Negative, when I square a negative, it goes positive. Then again, I square the numerator and the denominator. 1 squared is 1, 2 squared is 4, and that should equal 1. But 3/4 plus 1/4 is 4/4, and that is indeed equal to 1. So yes, is this on the unit circle? Yes, it is. For the next few of them, we did in class. If you have questions on the next few of them, again, please feel free to ask me. You can either email me or you'll see office hours posted as well. So ask if you have questions on the next couple on that first page, but I'm going to skip down to the next page, and we'll start with number 11. So 11 says, write an equation of the line that passes through the following points. And we have -3, 7, and -1, -5. And we want to write the equation that goes through. Okay. So when I have just 2 points, I can find out the slope by using that slope formula. And the reason that I care about this is because in the end, all I really care about is figuring out what y equals mx plus b is, right? That's my equation. I just have to figure out what m is, and I'll do that here. But once I've done that, I can then figure out what b is, and we have 2 methods that we talked about to do that. So let's figure out what m is. To figure out what m is, I'm going to call one of these points x1, y1, and the other point x2, y2. And so I'll just plug in these values. y2 is -5, minus y1 is -7, and then x2 is -1, minus x1 is minus -3. So that becomes -5 minus 7 is -12. And then 1 minus -3 is the same as -1 plus 3, and that is -2. And so my slope here is 6. So I'm halfway there. I already know m is 6, but I just need to figure out what b is. But knowing that m is 6 tells me that my equation will look like this. And this equation has to be valid for any point that's on that line. And luckily, I have one. I have 2, but I don't need to. I'm just going to pick 1 and plug that in. So if I plug this in for x and this in for y, I should be able then to solve for b. So y is 7, I'll plug that in. X is -3, plug that in. And then I just solve. 6 times -3 is -18. And so I add 18 to both sides. And it cancels out on the right-hand side, leaving me and isolating just an b. And b is equal to 26. And then to finalize the problem, I just write my solution. Right back up in here into y equals mx plus b form. I know m, I know b, so my final solution is y equals 6 in place of m times x plus b, which is 26. And I'm done. Let's look at 13. 13 says solve. And let's look at b. We have 4x plus 3 is equal to 2x minus 7. And these were the kind of the first algebraic solutions that we had to come up with. We had to use the addition principle and the multiplication principle. But here I'm just going to subtract 2x from both sides by using that addition principle, because the 2x on the right-hand side cancels out. 4x minus 2x leaves me with just a 2x over there, still plus my 3 equals 7. So all of my x's have been moved to the left. I want to also get my non-x terms and move them to the right, and I'll do that by subtracting this term here out of my left-hand side. So I subtract 3 on both sides. That 3 cancels out with a -3, leaving me with just 2x. 7 minus 3 is 4. And now I can solve all the way by using the multiplication principle and dividing both sides by 2. Divide that by 2, and I get x equals 2. Another thing that we talked about early in the semester was the domain. So if I have a function, let's say here y equals, let's go with 5 over root 2 minus x. So this is 15b. Now, our domain issues up to this point, we had more later, but we had you can't divide by 0. So when you have division, your denominator can't be 0. And then the other thing that we had was that you can't take the square root of a negative number. Later on, we also had logarithms pop up, and we had domain issues there where you could only take the log of a positive number. But for this one, all I'm really worried about are these two things, because I have both of these issues. There's division, where there's an x in the denominator, and there is a square root. So I have to take both of these into consideration, but I can take them into consideration simultaneously, noting that the denominator not being equal to 0 simply means that what's under this square root has to be strictly a positive number. I just can't let it be 0, otherwise I'm dividing by 0. And so my conditions here are that this 2 minus x that is under the square root has to be greater than 0. Right? If it were just a square root in, say, the numerator, or just a square root with no denominator at all, then I could set it equal to 0 with that inequality. But here it has to be strictly greater than, again, because it's in the denominator, and I can't let that denominator be 0. So here I'll subtract 2 and solve this inequality for x. That leaves me with minus x is greater than negative 2. And I'll divide each side by negative 1. And that leaves me with an x on the left and a 2 on the right. But this inequality switches directions because I divided or multiplied by a negative. And so that's my solution. The only numbers I can plug in here are numbers less than 2. And so know how to graph that. Right? It's not, in this case, it's not terribly difficult. You just plop a 2, it's strictly lesser than. So open the circle and then numbers to the left, right? But also know how to write that into interval notation, and that's all the numbers from negative infinity, which always has a bracket, a parentheses, and that goes up to 2, and that's in a parentheses this time because it's the strict inequality. Let's look at 18. F of x equals the square root of x minus 1. And g of x is x squared minus 2. And we're asked to find the following. So let's find a few of these. Let's find g composition f of x. And then let's find the f composition g of x. And then once we found those, let's note their domains. So g composition f is just taking g and plugging f into it. Well, it's the same as g of f of x. So that's just taking this f of x and replacing the x and g with it. So that is x squared, but it's the square root of x minus 1. That gets squared. And minus 2. Now we can simplify because the second power takes care of the square root. And so that ends up being x minus 1 minus 2. But that's x minus 3. And if you guess the domain based on your simplified value of g composition f, you might say it could be all real numbers, but that domain of f of x is carried all the way through. Because I can't plug in certain numbers for f, that means I can't plug in certain numbers into the composition. And so I have to worry about that inner function's domain. And that domain is that the x minus 1 under the square root has to be greater than or equal to 0. And so I just add 1 to both sides. X is greater than or equal to 1. And that is the domain. So this function, g composition x, is x minus 3, but it's only valid on that domain. Because I can't put numbers less than 1 into f and get a value that I could then turn around and put into g. So likewise, for f composition g, that's the same as taking f of g of x, or taking g of x and planting it into f. So it's kind of the other way this time. I'm going to take x squared minus 2 and replace that into the x of f of x. So that is, I'm going to have the square root of, instead of x, g, which is x squared minus 2, and then minus 1. But this is the square root of x squared minus 3. And so I clearly have some domain issue going on with f composition of g. So I need to check two things: the domain issue here and the domain issue of the original g of x. But g of x is all real numbers. There's no issues there. So this is the only real domain issue. I need to figure out what I can and can't put in for x into the final product here. And so, again, I set that part underneath the square root, x squared minus 3. That has to be greater than or equal to 0. But I can just add 3 over to both sides, right? This tells me x squared has to be greater than or equal to 3. Okay. But x squared is a squared value. If I square root this, this tells me that x has to be greater than or equal to the square root of 3. But it also tells me these numbers on the other side x has to be greater than or equal to the square root of 3. That means all of these numbers over here satisfy it. But since it's an x squared, anything that's to the left of negative square root of 3 is also going to be larger than 3 when I square it. So that is this portion over here, right? That would be like one of those problems where we had to graph and solve. If you look at it like this, x squared minus 3 is greater than 0. If we found our zeros, there are two zeros of this function. That's that positive and negative square root of 3. That's why these guys are here. And that breaks this number line into 3 regions. To the left of root 3, to the right of positive root 3, and then in between the two. And so where I find that this is positive, right, this expression x squared minus 3, where that's greater than 0, is to those values to the left and the values to the right. Okay, let's look at 19. 19 says evaluate. I'm going to just still this. I'll post it here. There we go. Okay. So we're looking at the difference quotient, which again, that's going to be a big deal when you hit the calculus. But let's pick a function here. I'll pick one that's easy, and then I'll pick one that's not as easy. So we're going to take a look at A to start. A is f of x equals 2x plus 7. And so if f of x is 2x plus 7, I'm also interested in finding out what f of x plus h is. And so I'm going to plug in x plus h. And that's just replacing the x in the original function with x plus h. And so I'm just going to rewrite this entire difference quotient using f of x plus h. and using f of x. So that is f of x plus h is this, which I can distribute if I like. This is 2x plus 2h. Let me just write that down here. And then plus 7. So I'll start there. It's f of x plus h, which is my 2x plus 2h plus 7. And I'm going to subtract off the entire f of x. So that's subtracting off 2x plus 7. And since I'm subtracting a function, I'm going to put that function in parentheses. And then this whole thing is divided by h. And then I just simplify. So I'm going to take this minus and distribute it through my parentheses here. This gives me 2x plus 2h plus 7 minus 2x minus 7 all over h. And things will cancel out. I've got plus 7 and minus 7 that cancel out, 2x minus 2x that cancels out, and the only thing that's left in my numerator is 2h over h, but since h is now a factor in my numerator, it'll cancel out, and I'm left with 2. So that was a fairly simple one. The other ones can get a little bit hairy. Let's take a look at, C. C is 3 minus x squared. And so if I put in f of x plus h, that's now 3 minus x plus h squared. And I can simplify that just like I did before. X plus h, right over here, I'll do this. X plus h squared is the same as x plus h multiplied by x plus h. And so I'll FOIL. X times x is x squared. X times h is xh. H times x is the same as x times h, so I'm going to write xh again. And then I have h times h, which is h squared. So I have 3 minus, and I'm going to leave it in parentheses because it's minus that entire expression. So x squared plus xh plus xh, I'm going to simplify to 2xh, and then plus h squared. But this minus gets distributed all the way through, so this becomes 3 minus x squared minus 2xh minus h squared. And this is my f of x plus h. So once again, putting it into the difference quotient, which is again up here, this is f of x plus h minus f of x. So I'll write f of x plus h. Minus f of x, but that's minus 3 minus x squared. And then that's all over h. And then I simplify. So I'll start by taking this negative and distributing it through. And I'll just rewrite everything. This is now 3 minus x squared minus 2xh minus h squared, and then minus 3, but then plus x squared all over h. And again, things cancel out. That's one of the beautiful things about this difference quotient is a lot of stuff cancels out, like a positive 3 with a negative 3, a negative x squared with a positive x squared, and the only things that I have left up top are these two expressions, those two terms. And so this is now negative 2xh minus h to the third over h. But you'll notice that there's an h in both terms up in the numerator, and so you can factor that out. That is an h multiplied by negative 2x minus h squared all over h. And the reason that I wanted that factored out is because now h as a factor on the left-hand side can cancel with h as a factor in the denominator. So cancels, cancels. And my final result is this term left up in the numerator, which is negative 2x minus h squared. And that's it. Okay. Let me clear this whiteboard as it's kind of starting to lag a little bit on me. And start with a fresh one. Let's take a look at 22. 22 says, just grab it here. All right, so 22 says this: determine if the graph of the relations below are symmetric with respect to the x-axis, the y-axis, and the origin. So let's do a couple of these. Let's pick just two at random. Let's do those two. So to find out, I'm going to replace, I'll start with x. I'm going to replace x with negative x. Now, if I replace x with negative x and I get the same function out, then that means this is if I get the same function back, then this is symmetric about the y-axis. And so let's check. Let's check B. I'm going to replace my x right here with negative x and see what happens. So doing so, I still have 2y squared. That equals 5. I'm replacing x with negative x plus 12. This 5 times negative x becomes negative 5x. And this is not the same thing that we started with. And since it's not the same thing, then this thing is not symmetric about the y-axis. But I'm going to then go back and try y, and I'm going to replace that with negative y. And if I get the same function back, then this thing is symmetric about the x-axis. So I'll try that. I'm going to replace y, starting at the original function. Replace y with negative y. I have 2 times negative y squared equals 5x plus 12. The negative y squared is the same as y squared, so this is 2y squared equals 5x plus 12. And that's the same thing that we started about. So this thing is indeed symmetric about the x-axis. And then finally, if I do both, if I replace x and y with negative x and negative y, and if I get the same function, then this is symmetric about the origin. So I'll do that. I'll replace both x and y from the original function. And that becomes 2 times negative y squared equals 5 times negative x plus 12. This negative y squared just becomes 2y squared, so that's the same. But this x over here, again, 5 times negative x becomes negative 5x plus 12, and this is not the same. So it is not symmetric about the origin. It's not symmetric about the y-axis, but it is symmetric about the x-axis. Okay. Let's try that with D. Let me just write D again so I can get a clear space to work in. D is y equals x squared plus 1 over x to the third plus 2x. So I'll go through the same process. I'm going to start by replacing x with negative x. And that is y equals negative x all squared plus 1 all over negative x to the third plus 2 times negative x. But this is, well, the negative x gets squared, that's x squared again, so x squared plus 1. So my numerator is the same, but this negative x in the bottom gives me a negative x to the third, and 2 times negative x is minus 2x. And this is not the same. So we'll go move on and say, let's replace y with negative y. And that's just negative y then equals, everything on the right-hand side is the same. But this isn't the same either. So I'm not symmetric about the x, I'm not symmetric about the y, but I might be symmetric about both, so let's try it. I'm going to replace x and y with negative x and negative y. So that's negative y now equals negative x, that gets squared, plus 1, all over negative x to the third plus 2 times negative x. Now, on the left-hand side, that's just negative y. On the right-hand side, that negative x squared becomes x squared plus 1. And then the negative x to the third is negative x to the third, and then minus 2x. And it might be not the easiest thing to see right here, but if I multiply both sides by negative 1, just to get the y back to a positive y, that does give me a positive y. But this negative 1, I can multiply in the denominator instead of the numerator. And so this gives me x squared plus 1. But that negative gets distributed through the denominator, and that becomes x to the third plus 2x. And this is the same thing that we started with. And since it's the same, then this is symmetric about the origin. All right, let's look at number 23. We want to determine if a function is even, odd, or neither. So let's take a look at one. Let's look at C. C is y to the third equals 2x squared Oh, I'm sorry, I'm looking at the wrong thing. That was the last question. F of x is x to the 6 minus x squared over x to the 4th plus 5x to the 8th. Now, the key here is if I put in negative x in for x, if I replace x with negative x, and I can simplify this and I can turn it down to the exact same function that we started with, right? F of negative x equals f of x. Then this thing is even. But alternatively, if I plug in negative x and this thing simplifies down to the negative or the opposite sign of f of x, then this thing is odd. But if neither one of those cases happens, then the function is neither. So the key, though, is I'm going to plug in negative x in for x. I'm going to find f of negative x and see if I can simplify it down to either the same function or the opposite function. So x to the 6, that becomes negative x, that gets raised to the 6, minus x squared, but that's a negative now, x squared. And then I have negative x to the 4th plus 5 times negative x all to the 8th in the denominator. But each one of these powers is even. So negative x raised to the 6, that's a negative times a negative times a negative times a negative times. There's an even number of them, so that's going to be a positive, and that's going to be x to the 6th. Minus the x squared is negative x squared now. It's negative times a negative. It's still positive x squared, but the function between the x to the 6th and x squared is still minus, so it's x to the 6th minus x to the 2nd. And the same thing happens in the denominator. Negative x to the 4th multiplies out to x to the 4th, plus, and then 5 times, but negative x to the 8th multiplies out to be x to the 8th. So this is the same function, which is to say f of negative x simplified all the way down to the exact same function we started with, and that tells you this thing is even. Let's look at three more. We'll look at 3 more, and we'll wrap up page 2 of these notes, and I'll stop this video, and we'll call this video 1 of 2, and then I'll start up another video to go through pages 3 and 4. So let's look at 24A. 24A says graph the following, and it gives you f of x equals 2 times the square root of x plus 5 minus 2. And on any final that had this question, you would end up getting a nice graph. Let me just still one real quick here. There we are. Okay, stop that. Okay, so the key here is to know how to manipulate an already known graph, right? So I know that if I were to draw the square root of x, I would start at 0. I would kind of come through 1, and then this would kind of level off. By the time I get to 4, it gets to 2, and it looks like this, more or less. And again, please forgive my drawing skills. This is not easy to make a nice, beautiful line with. But this is the square root of x, and you should know that. And the key here is then just to manipulate this square root of x. And what happens in this function here is that inside the parentheses, or inside the square root itself, I'm going to move left or right, and I'm always going to go opposite the sign that's in there. So this is a movement to the left of 5 units. And then after that, the next thing that's operating on the square root is this 2. And so this 2 tells me that everything gets stretched, a vertical stretch by a factor of 2. And then the last little bit is this -2 hanging out here. That's a shift down by 2. And this saves you from having to plug in x values. Plug in x equals 0, x equals 1. They're going to be terrible values because it's a square root function anyway. This just tells you how to manipulate what you already know. And so we'll do that. I'm going to move this thing to the left 5 units. So all of these, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the shift of left 5 units gives me something that looks like that, right? That's just a shift to the left. But I'm also going to stretch this thing by a vertical factor of 2. So starting there, I'm going to delete that. I'm also going to delete this one, maybe. I don't know. Yeah, I don't want it to get too ugly. So I'm going to delete this, but we're still there. That's where we're at. But I'm going to stretch everything. So I'm going to get stretched up here. Oh, so awful. That's such an ugly curve. It started out so beautiful. But my original one looks like this. So instead of being at 1, I'm going to be at 2. And then here, instead of being at 2, I'm going to be at 4 because everything gets stretched by that factor of 4. So again, let me see if I can make this not as ugly, but it should look something like this. And I won't judge your art skills on the final because clearly it looks like a kindergartner's trying to draw this. Oof, it just keeps. Oh man. All right. Well, I had it not too bad at one point. That's worse. But that's the factor of 2. That's the stretching factor of 2. But I'm going to take that curve now and shift it down by 2. So I'm again going to delete this because everything here gets shifted down by 2. This gets shifted down to 2, down by 2. Everything gets shifted down by 2. So this is down by 2. So my new function starts here, right, and goes through these points from before where they've been shifted down by 2. And then my final answer is, without all of that noise, it looks like that. And I just obtained that by manipulating it with the shifts and the stretches. All right. Let's look at 25 and 26, and then again, I'll end this video and put one out for the second half of the review sheet. 25 says, this. So if y varies directly as x and y equals 54 when x equals 12, find y when x is 8. So it says if y varies directly, so we should know that our function is going to be y equals some constant multiple of x. That's what that means. And if y is 54 when x is 12, that means 54 can be replaced for y and 12 can be replaced for x, and that's still part of this equation. Doing this, I can figure out what k is. If I divide both sides by 12, that isolates k on the right-hand side. On the left-hand side, 54 divided by 12, you can either write down the decimal, you'll have a calculator for your final. You can either take 54 divided by 12, or you can simplify it down to a fraction this simplifies down to 9/2, right? Or you can call this 4.5 if you like. It does not matter. But the question is, can you figure out what y is when x is equal to 8? So I know k. That tells me that this equation we started with, y equals k times x, is y equals, let's just say 4.5 times x. Right? But when x is 8, that means I can plug in 8 for x, and then it's just 4.5 multiplied by 8, and that ends up being 36. And then 26, finally here, let's look at this one. It's similar to 25, but now y varies inversely as x. And so we should know that the equation is y equals k, no longer multiplied by x, but now k divided by x. And I go through the same situation. If y is 12 when x is 5, I plug in 12 for y, 5 for x, and I can solve for k. I'll do so by multiplying both sides by 5. And so on the left, I end up with 60. And on the right, I have isolated k because 5 and 5 cancel out. So I know what k is. And that tells me that this equation is now specifically y equals 60 over k, or excuse me, 60 over x. And then they're asking you to find y when x is 6. So I'm just going to plug in 6 in for x, and that's easy. That's 10. So what is y when x is 6? Y is 10 when x is 6. All right. Thanks for this one. Again, I'm going to stop here, and then I'll do a second video for the second half of this review sheet. If there's any in here that you wanted me to cover and I didn't, feel free to just shoot me an email, and I can explain it, or or set a time to meet with you. But thank you, and see you on the next one.